Why the chi-square becomes normal. How can a right-skewed chi-square curve approach a symmetric normal curve? Chi-square normal convergence shows how a centered and scaled chi-square variable becomes approximately standard normal as its degrees of freedom increase. An unstandardized chi-square distribution has mean nu, variance 2 times nu, non-negative support. And right skew, it does not simply turn into n1 on its original axis. The visualizer demonstrates decreasing skew and moment matching while preserving the distinction between a finite chi-square law and its limiting reference. If q with nu degrees of freedom follows chi-squared with nu degrees of freedom, then eq with nu degrees of freedom equals nu. And var q with nu degrees of freedom equals 2 times nu. The standardized variable subtracts nu from q, then divides by the square root of 2 times nu. It converges to a standard normal distribution as nu increases. Chi-square skewness is square root of 8 divided by nu, which approaches 0. This provides a quantitative explanation for the disappearing right tail, while excess kurtosis, 12 divided by nu, also declines. Alternative transformations, such as the Wilson-Hilferty cube root approximation, can improve finite DF normality. This page focuses on the direct large DF relationship and does not implement those corrections. Compare chi-square distributions with nu equals 5, 30, and 100 after. Centering by nu and scaling by square root of 2 times nu. The goal is to track the standardized boundary, skewness, and central curve rather than comparing raw means. At nu equals 5, skewness square root of 8 divided by 5. Approximately 1.265, and the standardized lower boundary is about minus 1.58. The distribution remains visibly asymmetric, so a simple normal tail can be inaccurate. At nu equals 30, skewness falls to about 0.516, and the boundary moves to approximately minus 3.87. The center resembles normal more closely, while asymmetry remains visible in the right tail. At nu equals 100, skewness is about 0.283, and the boundary is roughly minus 7.07. Central standardized probabilities are substantially closer to normal, though exact chi-square calculation remains available. The sequence illustrates why degrees of freedom reduce relative skew and make a normal approximation more plausible. It does not establish one universal, safe, DF, tail location, accuracy requirements, and the original statistics assumptions determine whether approximation is acceptable. Try it free at distryscope.com.